In this problem, we're given a data set that talks about the waste recovered for composting material in the United States, and this is in millions of tons. So essentially, we have information on how much how much waste is actually converted into materials that can be composted and turned into basically soil and a soil amendment. And we have this data, and we want to determine a quadratic model. So this is going to require us to do a regression equation. And so we have here the data inserted already. We want to make sure that our stat plot is on. And now we're ready to go ahead and calculate the regression. So we'll go to stat calc. We'll do quadrag number 5. And just so that I get the full equation into my y equals screen, what I'll do is actually go to vars, y vars, function, enter, enter, and that basically shows me the typical equation, but then it also enters it into my y equals for me. So there's the full equation typed in, and I don't have to type it in by hand. Now keep in mind that if you do round it and use a rounded version of this equation, your answer may differ slightly. What I will write down is, I will just go ahead and write this equation down just with a few rounding places, just so that we have it. So we'll call this guy f of x, and f of x will be the waste, and x will be the years since 1990. And so f of x is negative 0.039 x squared plus 1.68x plus 4.12. Now we see fairly quickly that the fit appears to be mathematically very good at 99.3%. We will just go ahead and zoom stat just to be able to see, and there's the data. Those are the data points, and the graph seems to fit it quite well. As we get sort of towards the tail end, we're not really sure what's happening here because we kind of get a quicker drop off, but that could be just kind of a factor due to chance. And so now we want to know when did the amount of waste recovered for composting reach its maximum, and what was it? So we need to maximize this function, meaning that we need to determine where does its slope equal 0. So we'll find the derivative, and that gives us twice 0.039, which is 0.078, and that will be x, and it'll be a negative, plus 1.68. So that's the rounded version. And now we're going to replace the slope with 0, determine when there is a 0 slope for this function. We'll subtract 1.68, and then we'll divide by negative 0.078 to give us x. And that's going to be a positive number, so I'm not even going to put in the negative signs. Divided by 0.078. And that comes out to about 21.54. So we'll just round to 21.5. Now that appears to be in the year, well, that's 21.5 years after 1990, so that appears to be midway through 2010. If I've done that, no, excuse me, mid. So just to verify that this is in fact a maximum, we can't just assume that it is. So we will go ahead and do our first derivative test. So there's 21.5. And I'll pick x equals 0 over here, and maybe I'll pick x equals 22 over here. Okay, so I need to plug these into the derivative function to determine whether it's increasing or decreasing. And I see that f prime of 0 is going to be a positive 1.68. That I can just look at the derivative function and see if I plug in 0, I get a positive number out. Okay, now I'll do negative 0.078 times 22 plus 1.68, and I find that I get a negative 0.036. So f prime of 22 equals negative 0.036. That's a negative number there, and that means that its positive slopes here plateaus out at 21.5 and then drops back down. So indeed, this is a max. And the question really just asks us, when did the amount of waste recovered for composting reach its maximum? And then it asks, what was it? So we know when it happened. We want to know, well, what is this max? How big is it? To answer that, we all we need to do is go back to our original function that outputs the amount of waste as a function of the year, and we'll just do f of 21.5. So we need to figure out what that is, and I'm just going to use the equations in my calculator to check this. Now again, this can be conflicting because I rounded here, but I'm not going to round here. And my y equals, I have the full-blown equation, but it's okay, we'll get a pretty close estimate. And so we'll type in 21.5, and we get about 21.9 millions of tons of waste is being used for composting material. Now this is interesting because, in fact, here we're seeing 21.9, but according to this, it was in 2008 that the maximum occurred, and the maximum was 22.1. Well, keep in mind, going back to our graph, that this is not a perfect model, that it only estimates things, and we can kind of see that over here it's already reached its max, and it seems to be coming back down. So this is not a perfect model, but it does the trick for us.